In this video, we will introduce the C# class data structure. Now this video is going to be a short introduction on the components of a class. In future videos, we will go into more detail of the usage of those components. If you remember your hierarchy of C# elements, we start off with a namespace. A namespace is a folder, or behaves like a folder, that contains a bunch of classes. And then classes are containers that contain methods and other data members. In C#, the class data structure is a fundamental data structure. C# is a programming language that was built to be an object-oriented language. And because it was built from the ground up to be an object-oriented language, all code elements must be inside a class. Now this is not true for all programming languages. If you are programming in C or C++ or Python, these other languages do not require you to start inside a class. But in C# you have to begin you have to put your code elements inside a class. Now there are four main data members that can be found inside a class. We've already created classes that contain methods, but there are three other data members we will start working with. The first type of data member is called a field. A field is just a variable that's defined inside a class. Once you define a variable inside a class, that variable is accessible to all other data members inside the class. Properties are a data member that allow protected read-write access to field variables. And when we get to the video on properties, we will discuss why we might not want to make field variables directly accessible. Constructors are special data members that allow the initialization of field variables. Constructors are methods that are used usually one time when a class is kind of beginning its use. When a class is just kicking off, constructor methods can be used to initialize the other data members of a class. And then finally, methods. Methods are just containers of reusable statements. Hopefully we feel fairly comfortable about methods at this point. Now, when we start building our own classes, we need to understand access modifiers a bit more deeply. So there are three access modifiers we are going to be using. The first access modifier is called public. Any data member that is marked as public is accessible both inside and outside of the class. If a data member is marked as private, then this data member is only accessible inside the class. Now, if public or private, if the access modifier public or private is missing, then the data member is assumed to be private by default. Now, public and private access modifiers define where a data member can be used. The static access modifier defines how a data member is used. So any data member that is marked as static is used from the class. It is called from the class. Any data member that does not have the static access modifier is considered a non-static data member. Non-static data members are used from an object built from a class. And let's try to visualize this. Here I have so here I have a class named myClass. And then I'm visualizing building a new data type, something called an object, and we will go into this in more detail in a future video. But if I can build an object from my class, I can build an object from the class. Here inside my class file, I have defined two methods. One method named hello, which is defined as a static method. The second method is called howdy, and it does not have a static access modifier. So howdy would be considered a non-static method. If I wanted to use my static method, I have to call it from the class. So I could call it by saying myClass.hello. I'm calling the static method from the class. If I wanted to use my howdy method, however, I would have to go to an object built from my class and call the non-static method from the object. So static methods or static data members are used from the class. Non-static data members are used from an object built from the class. Now, a class has two main roles in C#. The first role is just as a library of static methods. So when we build classes that contain a bunch of static methods, the purpose of these classes are just as a library to hold a bunch of common methods. For example, the console class. We've been using the console class a bunch so far. The console class contains a bunch of static methods. For example, the writeLine method, the write method, the readLine method, readKey method. And these methods allow interaction with a console. So there we have a bunch of static methods that are grouped together and put into a console class. This is an example of a class that is being used as a library of static methods. What we're going to get into soon is using classes as blueprints for building objects. And what does that mean? Well, we are going to want to model real-world entities as new data types in C#. And the class defines the rules on how we can make that happen. Here are some class conventions that we want to think about when we are building new classes. Each time we build a new class, the new class should be defined in its own separate file, and the file should have the same name as the class. So for example, when we've been building our console applications, we start off with a program class, and that program class is defined inside a file named program.cs. Now, the syntax allows you to create multiple classes inside one file, but this is bad convention. Classes are, one of the benefits of classes is being able to share them. And so the more classes you put inside a single file, when you want to share one of your classes, you're forcing the sharing of the rest of them. So we are going to try to follow the rule whenever we build a new, or whenever we add a new class to our file or our project, that class should be inside its own file. Some access modifier conventions. Well, we will learn in future videos why we do this, but when we declare field variables, we should set those field variables as private, okay, not public. The reason we do this is because of some of the fundamental principles of object-oriented programming, which we will get into later. But we want to protect our field variables from being set to bad values. So we are going to, whenever we declare a field variable, we should set it to be a private data member. Other data members, such as properties, constructors, and methods, are usually public. Now, there will be some cases where you might want to make a method private, but for the most part, if we want these to be widely used, we want to make these other data members public. So field variables private, the rest of the data members can be public. As far as naming conventions go, field variables should begin with a lowercase letter. All variables in C# really should begin with a lowercase letter. When we declare a property, properties should be named starting with an uppercase letter, and typically properties share the same name as a field variable they are protecting. We will get into this later. Methods should also begin with an uppercase letter. So when we are naming our data members in C#, field variables should be lowercase. Everything else we name should probably be uppercase. All right, this is a very brief introduction to classes. The next couple videos will go in depth into topics such as how do I instantiate an object, how do I build an object from a class, how do we build good fields and properties, how do we build good constructors, etc.